Welcome back, guys. My name is Austin from awfulmedia.com, and this is the start of part 3 to the making a game in Unity 3D, or making a simple game, whatever it is. We're making a game in Unity, and it's going to be a pretty simple game. And what we have so far is we have a player that we can control using some physics forces, pushing it around the world based on input. Then we have an enemy that has a patrol point system where it can go from point A to point B to point C and continue on that way. And that's pretty cool. And we have a nice little lighting setup and all that. So we're making some pretty good progress. It's taking us a while because I like to explain everything as much as possible, because I want you to understand what is actually going on. I don't want you to watch this and only know how to make this game, because that'd be silly. You didn't learn anything. You're just going to copy what this game is. I want you to be able to come from this series and be able to make a different game. That means you learned something. If you can take what you've learned here and apply it to making a first-person shooter, which you almost could, you would have learned quite a bit, because that's a pretty cool thing to do, is to take knowledge and use it for other things. That's kind of what it's for. What I have now is I have this in the scene editor. It's the same, right? And then I saved this scene as level 1. I did that by going File, and I went to Save Scene, but now I'll do Save Scene As. And I can save this as level 2. And now I'll have a version of level 1, the same thing, but as level 2. But in level 2, I can say delete the floor. Then I'll go back to level 1. Oop. Double click on that. Yeah, I want to save. And there's a floor there. Level 2 though, no floor. So the difference between levels is what is in your hierarchy here. That's the most important part. You can add, remove things, attach and remove things, and that's how you design levels, how you develop levels. So you have a game that has 50 levels, you'll most likely have 50 scenes. That would be the idea, and you'd have a scene for your main menu, different kind of screens like that, a menu with some buttons. Then that would be a scene of its own. But I want to take scene 1. We can delete scene 2, I don't need that. But in scene 1, I want to take it and add it to my levels. Now I have level 1. Now if I was to go File and go to Build Settings, now this menu is where we can set up the settings for the build of the game. And that's like the, think of it like the rendered version. When you're working on a video or doing some special effects or something, you render out the video. And the end result is everything compiled together to make that video. Well, this is the same thing with the game. It takes all of your scripts, all your classes, all the objects, and it compiles them all together into this exe, if you're building for an exe, and then you can just run that file and it'd be your game. It would have the libraries you need, it would have all the assets you need, it has everything you need all packaged nicely in a file, in a folder. So say we want to build for a PC, which I'm on. Well, we want to add a scene in the scenes in build. So to do that, first of all, since I am in level 1 already, I can say add current. And that will add level 1 to the scenes in build. Now, throughout your work, you may add a lot of scenes here, and that's fine. You can uncheck them if you don't want them to be in the build, and check them if you do. Notice this integer right here. This refers to the ID of the scene. I guess we'll call it the ID of the scene. So it'll increment by 1 each time a scene is added to the scenes in build. And you can refer to these levels by the integer or by the string name. Keep that in mind. Now the big thing about Unity is its platform support. Look at that. What one piece of software does this? That is crazy. But you can do a web player, which is really cool. So you can render out a game, build a game for a browser. So if you play on Congregate.com, you have probably came past a Unity 3D web game. And this is how you do that. You go to web player, a few settings here, not that important, and you click build. You can click build and run. It'll it'll run it for you after the build is finished. But say I want to build a game, and I'm going to say, yeah, this is a development build. And what that'll do is in the bottom right, it'll say development build. It's pretty much the only difference you'll get there. Script debugging we won't get into. Now I'm going to click build. And it wants to know, hey, where do you want to put this build of the game? I'm going to right click here, or let's go new folder here. And I'm going to call this folder builds. So we will store all of our builds throughout our game's progress in the builds folder. I don't have a decent naming convention for these. If you're using some kind of versioning system, you may have a better naming convention, but I just start with, if it's alpha, then I use an A for the first letter, and the version of the game, which for me increments by 1 based on the build. Nothing technical there. It's just A1 for the first one, A2 for the second of the alpha, A3, and it keeps going like that. Do whatever you want. Just do something you will understand. It's for you to see. It's not for somebody else. So do something that makes sense in your head. For me, A1 makes sense. And you see I can publish as an EXE. I'll click save. It'll build the scene. Don't worry, the scene is still there. It's just it's doing some stuff. So it disappeared in the game view for a second. And now in the builds folder, I have A1 and I have A1 data. But what we have right here is an application file. Now we can launch that. I'll double click on that and we'll get this. I'm not sure what it's called. It's like a launcher thing for Unity, but it's built in. You can turn this off if you want to, and you can have your own menus in your game where you select the graphics settings and the inputs. But if you're just doing quick testing, this is awesome. So you can just set up how you want everything to be before you even launch the game. So you can bind all your controls and set your graphics. So if I do 1920 by 1080 and I want it to look fantastic, not windowed full screen please, I hope this player or this recorder will record this. So I can take this and give it to somebody and they can play it. And that's pretty cool. That's how you do that. Any other things in the build settings we have to look at? I was asked if for the side-scrolling platformer that we're going to be doing, if it could have Android support or mobile support, they said. But for me, it would be Android. I don't do Apple stuff. So my response to that would be, I would love for it to be supported on Android, and we may go over controls for that. The only difference that we would have to work out would be the controls, and the GUI is usually a bit different because you're going to have different resolutions, and you have to account for that. But I would love to do that. So that is the build settings. Player settings here. This will give you a few options dependent upon what you're building for, and you can change this. Just look through it. You can set up an icon, a splash image, which are pretty cool. This is for PC, Mac, and Linux standalone. You have the web settings here, and you can go through that. It's pretty cool stuff. But all of this is pretty important if you're doing an official build of your game. So make sure you go over this. It's all pretty self-explanatory, really. And it's something important to look into. But enough talking about all that stuff. Let's actually get into working on our game. So what I want to do is I want to kill the player when I run into the enemy. So when I hit the enemy, we're going to detect a collision and then do something with the information that we got back. So when we hit the enemy, do something, and then what we want to actually do is not destroy the player object, because then we would lose some information that the player object has. Say we have something in player movement that we don't want to reset whenever we respawn the player. Well, then when you destroy it, you're resetting all that, because all of that information is now gone. The object doesn't exist anymore. So a really good way to get around that, and actually a pretty cool, efficient killing system or a respawn system, is to not destroy and reinstantiate an object, because then you're destroying and removing it from memory and then adding it back in. What you can do is just move the player from where he died to the spawn point. You can delay this. You can do something, to make it seem like he's dead for longer. You can have like a death animation, all that stuff. That's fine. But afterwards, instead of destroying the object and then reinstantiating it, just move him. And we're going to do that. So we'll detect these collisions in player movement it may be best to create its own class and work in it that way. But we're just going to keep it simple, all in a single class here. Now, you probably noticed that my text is huge. That's because I do not want to do the zooming and stuff. I just want to be able to record this, go through and do a few edits, and render it and get it up. That will be good for me. It'll be quicker, and you guys will get quicker videos. The way I do them now is I have to go through and zoom in on the text and zoom out when I go back to the player or to the editor and then zoom back in. And I hate doing that. So for now, we're not going to do that. So I want to detect when I hit the enemy. So I'm going to set up a built-in function. It's a void with a return type of void, and it's called onCollision enter. Now this method requires a few parameters, or one parameter, and that parameter will be the collision parameter. We'll call it other. So what we hit will be stored in the other. Then we can access the information through that parameter, use it as an argument. We've been over all the stuff in the introduction to C# stuff, so I'll put a link on the screen once again. Go check that out if you have no idea what I'm talking about. So we're storing the information in other as an argument we can use. And then we can use, say, other dot, and we can grab like the transform position of the object that hit us and all that stuff. So what we want to do, though, is we want to see what object we ran into, because at the moment, this message will be called right here, will be called every time we hit anything that we can collide with, that we can detect information from. So we're a rigid body, and we have a box collider. So we will detect collisions with other objects with colliders. And we want to make sure we're hitting the enemy and not just hitting anything and dying, right? So the way we can do that is I have my game still open. Let's close that. Is I want to add a tag to my my enemy. So the enemy is named enemy, correct? But we don't want to access the enemy name when we hit him. We want to tag all of our enemies with a specific tag. That way any enemy with the enemy tag is a bad thing. So I could call this, like, if this was an ogre, he would be called ogre, but we would add the enemy tag. Now this is a tag, and that's the layers, which we'll get into later on. But the tag we want to do is add tag, and under tags here, notice this is an array, and we want to add, we'll just keep it at 1. We don't have to change it ourselves. Each time we add one, it will add 1 to the size. So I want to call this enemy. Notice I added 1, and it added an extra space in this array for another one. It's pretty cool. Now I'm going to go back to ogre. I'm going to go tag and add the tag of enemy. And now I can detect the tag of the object we hit. If that tag is equal to enemy, then I want to do something. So I can say under the in the method for detecting collisions, I can say if, and then I want to check the tag. So I'll say if other.transform.tag. Notice I'm going through the transform to grab the tag. You can actually do it a different way too, I'm pretty sure. You can go through the collider and grab the tag. Which is more efficient? I'm not too sure. Can you go through the game object and grab the tag? Yeah, so figure out how you want to grab the tag and go about doing it that way. I'm not sure. I think they're all pretty much the same when it comes down to efficiency. So I like to go through the transform and grab the tag. Then I can say if the tag is equal to a string. So the tag is going to be a string. The name is enemy, which is the string we want to check for. So I'm going to say if the tag is enemy. Then if it is, that's when I want really quickly here, print out I hit enemy. Okay. Now go back to Unity, go to our console, and I want to click play. Now if I run my character into the enemy, he went off screen there, notice it says I hit enemy, I hit enemy. But notice it only does it when I run into the player, or into the enemy. But I am colliding with the enemy for quite a while. So you would think, maybe you would think, possibly, that it should be throwing this every frame, because I am still currently colliding with the enemy. The reason it doesn't is because this is on collision enter. So whenever the collision is started, this method is called. There's a different one we could use for on collision stay. So as long as the collision is underway, it would be called. So if I go hit the enemy now, until he comes up there, notice now every single time, every single frame, I only want to check the collision once. If it happens, you die. That's how it happens. So then I want to set the position of the player to equal the spawn point. But what is the spawn point? Let's figure that out. So when the player is spawned in the world at the beginning of the map, he is spawned wherever I place him. So if I put him right here, this is where he starts out. He's over there now. If I put him over here, he's over here. So what I want to do is set the place that he spawns to be where I place him at the beginning of the level. And the way we can set that to the spawn point is I will create a private. We will create a private. What do we want to do? A vector3 or a. Let's do a private transform. And then we could say spawn. Just spawn. At the beginning, we can say spawn. Or we'll do a spawn is equal to. No, we'll do a vector3. I'm trying to figure out the best way to go about this. We'll do a vector3, and then we'll store the coordinates of our spawn position in the spawn vector3. So when we start, I want to set the transform.position. The position is in vector3, right? So it'll pass an X, a Y, and a Z to the spawn. So now whenever the game starts, it's within this script being instantiated or being initiated, then the transform.position of the player will be stored in spawn. So whenever I die, I want to set my transform.position to be equal to spawn. Now if I run into the enemy, it's spawning me there, but the place I spawn is under the enemy, so that's not really the best example. There we go, though. Notice I hit him, and it puts me back at the place I spawned. The X, the Y, and the Z. Even the Y, though, so now I'm still above the ground when I spawn, and then I fall back down, which is what I want. It kind of looks kind of cool. So that works. But in the example, I had, when I died, I had this explosion of particles. And it looks kind of cool, so we want to go over how to do that. Now, with Unity, it is extremely easy. There is a built-in particle system that honestly is pretty good. So we want to create a particle system in our world. Now, the first thing we want to do is actually just create it. We're not going to do anything with it yet. We're just going to create it, make it look how we want it to look, and then we'll work on adding it to the player, then spawning it in his location when he dies. So create a particle system. I went game object, create other particle system. Now notice, when I have it selected here, that it will simulate for us in the scene view and the game view. So we can see how it looks while we're working on it, which is pretty cool. We can pause and we can stop, and then we can continue the simulation. There it is. Notice it's under the ground quite a bit, so I want to bring it up to 0.25. That is not 0.25. And 0, 0. So that's what our particles look like at the moment. I want to lower the duration, so when the explosion happens, I want it to be pretty snappy. I want it to explode into particles and then stop emitting particles. So we'll do like 0.15 seconds. So it's going to be pretty quick. You can't tell that at the moment because we have looping checked. But if I uncheck that and then I stop this and I do simulate, notice it only had time for one little white ball to come out. And that's fine because we're going to do it a bit quicker than that anyway. So let's go back to simulating on the looping being true. So now the start lifetime, I don't really care too much about. The start speed though is kind of important. I want them to explode out of there. The start size, we won't get into, we don't need that. What we do want though is we want some gravity. So I want to up the gravity multiplier. which is going to, as it progresses up, it's also going to be having some force pushing it back down, so you get that nice, that arc there. And the color's fine. Now the emission, we want quite a few to emit, so I'm going to up that just a bit. Now one thing, notice the particles are just falling straight through the floor and then going on for a very long time, if not forever. So the lifetime will actually bring that down. Something like that. That looks good. But I want these to collide with the floor. So I want to go to collision. Now, see this little circle right here? That is actually a checkbox. You check that and it turns that to true, and now you can play with the settings that apply to that specific category. Now, I want to set what it collides with to be world. So everything in the world that has a physics collider, anything with a collider, it'll collide with. Turn it to true, and notice it starts bouncing off of the ground. Also objects with colliders. Notice though, it is quite bouncy, and we can affect that with this bounce is on 1. We can go, ooh, make it just bounce unrealistically, or we can turn it down to something a bit more cool. Something like that. 0.55. It collides with everything. Now you can set this with layers. Now that's something we was talking about earlier. Layers are these things right here. You can add layers and use your own custom layers and determine what collides with these particles. Pretty important. Now the renderer is kind of important for us because these little, I don't know, little orbs are pretty stupid looking. So we want to set up a texture that isn't quite so stupid. Luckily for us, it comes with a default texture that I like. The default sprites material is quite nice. I believe this may be only accessible in 4.3, as that is when sprites are a thing. So make sure you have that version. It may not be true, so don't hold me to that, but that would make sense. Notice it's quite ugly though, but we'll work on that. I want to select the sprites though, as it is just these squares. And you can use your own graphics, you can use things with alpha and stuff like that, and it's really quite cool. So this particle system is pretty impressive. Now what we want to do now is lower the size. We don't want the size to be so large. We will do something like that. And what we can do is we can make this large at first and then make them get smaller over time. So if I was to get this arrow right here, I could do a random between 2 constants. You can use a curve, which might be more helpful for you, or you can do a random between 2 curves, which is pretty cool as well. And I didn't mean to do curve, I don't want to do a curve. So I'm going to do random between 2 constants. Now this we can set up to be like, who knows? That's pretty cool. I like that. Let's bring it above the floor so look, this is coming from nothing. Now one thing I want to change is the emitter. Now this shape is something that we can change by going to the shape. Notice it is a cone, and we can see that here. We can modify this cone with these little points here. We can make the cone different sizes. We can bring it down, bring it up. It's so cool. It is so well done. So the cone, I want the cone to be a, I was thinking a hemisphere. Yeah, something like that. It looks about like the size or the shape of an explosion, doesn't it? I wish that didn't render through the ground so I could actually see it. Put that 0.25. Okay. So that is the explosion for when we die. Maybe a bit more force. Let's do a how's that? Now if we turn off the looping, I want to just check that please, thank you. I want to stop it and I want to simulate it. Okay, that's not going to be enough for an explosion. So we want to do like a 0.25. Come on. That's too much for an explosion. We want like The emission's not enough. We can turn the emission up. I'm just playing with these numbers. I did not have anything like this to go by. I'm just looking at it and I'm like, yeah, that'll work. That'll work. Let's do that. So now let's simulate that again. Okay, so now I want to turn this back down to like 0.25. Just playing around here. 0.25 is too long. I don't like the way that looks. See, I like that, but I want a few more. This emission thing is going up. That's a lot, though. That's almost double. Yeah, we can do that. I like that. That's kind of like sparks flying out. That's nice. And notice it is the same every time you do that. It'll be a bit more random when you actually have it in a world, but it's just simulating based on hard numbers at the moment. So that'll work for us now. Now what I want to do is take this particle system and create a prefab that contains its information. So to do that, I will first go to Objects, go to Prefabs, and I will store the particle system, which I will call Death Particles. That sounds cool. Drag that into my Prefabs folder. I now have a Death Particles prefab. And I can just drag this out here, drop it, and poof. So what we want to do with this is we want to instantiate this at the site of my player's death. So to start out with that, I want to go up here and create a public. Now this will be a game object. This will be the variable that will contain the prefab for my death particles. That way we can just reference the object, instantiate the object in the position of the player, and then kill the player. So game object is the variable type. Then it will be death, or just, yeah, we'll do death particles. Now down here, what I can do is when I do the moving my transform, or moving my position, I can do an instantiate. Now, have we went over instantiate? I don't think so. Instantiate is just a method that you use to create an instance of an object at a certain position in the world. Notice the arguments here is we have the original, then we have the position and the rotation. Now the object, which is called original, would be the variable that contains the particles that we want to use. So that would be death particles. The position would be the position of the player right before he dies. And since we're doing this before we move him to the spawn point, we have his position right before he dies. And that would just be transform.position. The reason that is because we are on the player movement class, which is attached to the player object. Now the rotation, this may need some playing around with, but it requires a quaternion. A quaternion is something that we're definitely not going to go over because it's complex and it's ridiculously stupid, and I wish they didn't use them. But all we need to know for now is we don't want any rotation. And the way we can set it to 0 on the rotation would be quaternion dot identity. And that will give us no rotation. We may have to fiddle with that, and I'll show you how if we need to. We'll use Euler angles to do that if we need to do that. Now if I go to the player, you'll see one more field here now, death particles. I'm looking for a game object. So I can take my death particles, which is a game object, and drag it to the death particles variable. Now it has the information it needs. If I click play, notice it spawned out there. Oop, that works obviously. But the reason we had particles here is because we have them still in the scene. I'll just delete those. I can delete those and not lose a single thing. Now we went over prefabs earlier, but I didn't really talk about how to use them. Now an ogre, say I have 2 ogres. I will hit Control D, drag the other ogre here. Say I modify a value on this ogre. I don't know what I want to do. I'll just change the size to 212 on the X scale for the box collider. And this other ogre doesn't get that information. They are an instance of each other though. They're an instance from another object. But so I can make these share the same information. I can change this one based on this one's properties. And the way I do that is I can go to this object, go to the top here and click Apply. Now this one will contain the same information. All prefabs that were created from the same object, when you do an apply on a prefab, will get the update. Very important to know. So that's that. Bring the box collider back down to 1, click Apply, and now let's go over the death particles. Oops. Oh no, what did that do? Oh no. Oh, that happens, I guess, right? I managed to add 2 patrol scripts somehow. Don't know how that happened. Don't need 2. I need 1. I'll remove this one. Now I'll add my patrol points back in probably a different order, actually. If I click play, he should do the same thing. I survived that somehow. Now if I run into him, he's going backwards, but that's fine. Notice I die, I go to my transform or my position here, and then particles spawn at my death position. Everything seems to be fine. The particles explode and then die out. But notice these little gizmos here. This is showing me that particles, they're shurikens because this is called the shuriken particle system. What's what the type of particle system it is. But notice they're still here. In the hierarchy, I still have these death particles. There are clones because there are instances of another object. And that would be the definition of a clone. So we need to clean up our mess after we are done with the particles. And the way we can do that is we can create a class that we can use for a lot of stuff, really. I will create C# script, and I will call this script destroy. Now this destroy actually may interfere with another, no, it won't interfere. So I can open this up. Now in here, oh, I named it accidentally to the default. Make sure the class matches the name of the script file. I want to set up a variable that will contain the lifetime, because what we're going to do is at the start of whenever this script is initiated, we're going to do a destroy. And we're going to destroy the game object that this class is attached to. But we're also going to pass it a time value. And this time will say, okay, so I'm going to destroy it, but first I have to wait for this amount of time. Now it does not require a time value, but we can use one. So I could say after 5 seconds, I want the F is for float. By the way, it's a float type. I want the game object to be destroyed. But I want this to be more dynamic for us. I want us to be able to attach this destroy class to another object, modify the time in the inspector for the lifetime, and then that be that. And after that amount of time, it dies. So we can do that by saying public float lifetime. Then pass the lifetime variable to that. And we'll set a default for the lifetime. Will be 0. And there we go. Now go back into Unity. I will attach this class to my... Oh, first of all, let's go to our prefabs. I want to drag another version of the particles out. Go to my classes again, and then grab the destroy and just drop it on death particles. Now down here we have destroy the lifetime. Now I can set this to equal what we would expect the particles to do. After a certain amount of time, all the particles disappear anyway, and we can extend that lifetime as well. But what I want to do is, I just want to do like 2 seconds. We're not in a hurry to get rid of these the objects in our hierarchy. They're not doing anything anymore. They're just there. So we're not in that big of a hurry to destroy them. So after maybe 3 seconds, might do more than that, we'll see, I'll destroy the particles. Notice those that got destroyed because they were there to start with. But if I do that, what did I do? What did I do? Oh, I don't know what I did. Now it works. What did I do? Anyway, notice they are cleaning themselves up now. So after 3 seconds, the particles vanish. And that is long enough for the particles to play out and destroy themselves. But they only destroy the individual particles. They don't destroy the actual emitter, which is what we are doing. And that is that. Now, next time we'll work on setting up a level, and then we will set up the goal to actually take us to the next level and go on from there. Now, I said in the last part that we would do a level select system. We're still going to do a level select system. I don't know what kind yet. It might be best for us to do the overworld map system where you go through, like in Mario, you walk from level 1-1 to level 1-2, and when you're on that space, you hit A, and it takes you to that level. We could do something like that. That would be pretty cool. And you could take that information and even make your own just menu-based level select, because it would be the same principle, but you probably couldn't go the other way. You couldn't go from learning the menu system to learning the overworld system. So I think we should focus on the overworld system. It'd probably be cooler anyway, and that's pretty cool. So I want to be as cool as possible when making video games. And we'll get into that. I was asked how to do, well, not how to, but somebody was wondering, how do people make objects in Unity? And you don't really. There's a few editor extensions you can get on the asset store that you can actually make objects, model, play around with triangles and vertices and all that stuff in Unity itself. But I would focus my time learning some kind of modeling software such as Blender, Maya, Max. There's quite a few, Cinema 4D, quite a few for you to look at. Blender is free though, and it's pretty powerful actually. It's pretty good. So I'd focus on my time on Blender if you wanted to learn how to do the game art stuff. But we will do a couple things in Blender, nothing fancy, because I am not an artist. I can't make a humanoid. I can't make a creature of any kind, but I can do a few objects, like props, or we're going to be doing a couple traps for this game probably, and we will model those in Blender, as it is free and accessible to everyone. If you can download it, it's accessible. That's it for this part though. My name is Austin, and I do appreciate you watching. The first part and the second part were so successful relatively to my other videos, and I'm super happy. So thank you guys for watching. I'll see you next time.